Got to repeat all that for. All right, so it's Thursday, test tomorrow. By the way, the stuff that's due tomorrow, it's on the board over there, but it's worksheets 1, 2, 5, and review. So remember I gave you a packet and then we threw away half the packet. So the first 2 worksheets from the packet, and then the worksheet 5, which you got a couple days ago, and the review worksheet, which you got yesterday. So 4 things due tomorrow. It is open notes, so you'll turn those in when you turn the test in. But just so you know what's due. It's 4 things. And again, you can throw away the rest of that packet other than worksheet 1 and 2. All right, how about questions from whatever this thing is, worksheet 5. Whoa, I did such a good job teaching it. Everyone's good. I don't know that we did any like 40 through 45 yesterday, or 39 through 45. Questions? No?
Can you show us how to do one?
Sure. You got a preference on any of those?
Like one of the ones. Can you do 45?
Let's look at 45. Inverse cotangent of the tangent of pi over 3. And while that other stuff's getting on screen, remember we're not ever going to do those. 45. Tangent of pi over 3. So tangent of pi over 3. Let's see, that'd be right there. I can do the y over x thing, but the tangent 3 trick, it's also a tongue twister, all the alliteration today. The tangent 3 trick is great because the tangent of pi over 3 is going to be the square root of 3. If you don't memorize that, then that's fine. You do the y over x thing, root 3 over 2 over 1/2, and soon enough you get the square root of 3. But then we need the inverse cotangent of square root of 3. Well, messing with tangents is tricky enough. I really don't want to mess with cotangent. So let's switch that. Actually, before we switch that, let's remind ourselves that inverse cotangent has to come from 1 or 2. So inverse tangent. So tangent and cotangent are reciprocals, so I'll flip the square root of 3 to be 1 over square root of 3. Which I don't really like because now there's a square root in the bottom. But that's an easy fix. So inverse tangent of root 3 over 3. Well, this is the second part of the tangent 3 trick. And that is, if there's 2 3's, well, 2 3's make 6. So the angle that happens at is pi over 6. So 45 is a unit circle question, unlike most of the others. And it's just a 2-part unit circle question. Any other, or what other questions? We got time today. No new information today, just 43. Secant, inverse secant of the secant of 7 pi over 6. Secant 7 pi over 6. Let's see, that's right there. Secant goes with cosine, flip of cosine. Cosine is the x coordinate. So negative root 3 over 2, but I need to flip it. So negative 2 over square root of 3. And normally I would fix that, but since I'm about to do an inverse secant and I'm going to flip it again, I'm not going to fix it because as soon as I fix it, I'm going to have to flip it. So I'm just going to leave it alone for now. Inverse secant, well, secant and cosine come from 1 or 2. It's negative, so it's got to be in quadrant 2. And I don't want to think about secant, I'd rather think about cosine. Inverse cosine of negative root 3 over 2. So second quadrant, I want my x-coordinate to be the long side. Well, if the x-coordinate is the long side, that would make this a shallow angle, which would be over 6. And in the second quadrant, that would be 5 pi over 6. Picture problem, or were those easier? 25 through 38. A couple of those were not possible in there. I'm trying to look and see. Yeah, okay. That's why we would not have questions. We haven't tried them. So let's see. I'm going to press pause, and we'll come back and work these in a minute. So just look in. Many of you haven't tried these yet. So try 34 and 35, and then we'll go over those two. Number 34. Inverse tangent is 1/2. See, tangent is opposite over adjacent, or y over x. Inverse tangent comes from 1 or 4. So it's positive, so it's got to be in quadrant 1. Opposite over adjacent. So this is not a Pythagorean triple, so I've got to do a squared plus b squared equals c squared. I mean, that's not a hard one, though. So that missing side is square root of 5. So again, use the inside stuff to draw the picture. Use the outside stuff to answer the question. Cosecant goes with sine. So cosecant would be hypotenuse over opposite, or r over y. So square root of 5 over 1, which would just be square root of 5. Inside stuff, draw the picture in the correct quadrant. Outside stuff, use it to answer the question. 35, a cosecant of the inverse cosecant. Let's see, cosecant goes with sine, so that's h over o. It's positive, so I know it's quadrant 1. Hypotenuse is 5, opposite is 1. The missing side is square root of 24, 25 minus 1, which reduces, but I'm not going to reduce it yet because I'm peeking ahead. Cosecant is hypotenuse over opposite, which is 5 over 1. Well, that kind of makes sense. The cosecant of the inverse cosecant, those undo each other. This is like, sort of like the square root of x squared. Well, those undo each other, and you're right back to x. So it's the same thing there. Although, you should probably go the long way on these, because this undoing thing doesn't always work. Like, let's look at 42. Is one where it doesn't quite work. So inverse secant of secant, you think, oh, those just undo each other, so the answer must be negative pi over 3. Well, let's see what happens. Secant of negative pi over 3 is the flip of cosine. Cosine's 1/2, so secant would be the flip of that. So 2. The inverse secant of 2. But the inverse secant has to come from quadrant 1 or 2. So I'm not going to get an answer in quadrant 4. Cosine then is 1/2. That happens at pi over 3. So for this one, it didn't. The secant and the inverse secant didn't exactly cancel each other out and leave us with negative pi over 3. So the safest way is to just work the problem. I mean, there's ways to get around it, but the safest way is to just work the problem. There's not enough of them on the test to worry about the shortcuts around it, just because there's not that many to worry about. So just work the problem as normal. All right, that's a bunch of those. So we'll pause or stop there for going over homework. The review has a few of those as well on it. I would say that just to keep the review short and on one page, it doesn't have a whole lot of these problems on it, primarily because you've got a whole bunch of them on this worksheet, and this worksheet is the most recent thing. So I would just say the review is not, phrase this, it's not weighted the same as the test is weighted. The review has more proofs and identities. The test has more of these type problems on it. So the review shows you everything that's on the test, but not in the right proportions, I guess, is the easiest way to say that.